All right. Welcome to finintro. This is going to be notes on chapter 7. And I'm just going to do some notes here in general. We're going to start off where expected return and our graph were before, and we're going to end up at the CAPM. And we're not going to spend a lot of time here. I'm going to try to keep this as simple as possible. But let's go over expected return again really quickly so we're all on the same page. Okay? So expected return is the forecast of the return that an asset will earn over time. And the way that we calculate expected return is by figuring out what the historical prices of a stock look like. More to the point, what the returns are. So here's my stock, and let me switch colors. And here's my returns. And the returns are very simple, right? They're calculated by the final value minus the first value. So then in this case, in the case for this one, there's no return here because there's not a previous value. But in the case of time period, let's say 0, 1, 2, 3, and so on. In the case of time period 1, this guy is going to be 101 minus 100 divided by 100. And that's going to give me 1 over 100, and that's about 1% return. So in the course of year 0 to year 1, or month 0 to month 1, whatever, it's going to be a 1% return. Does that make sense? This is nothing more than what we've studied in the past. This is final value minus initial value divided by initial value. That's it. And so if I look at the next series of these, this is about a 1% return, 1% return, -1. This is 2 and 8 is about 6%, right? And then -1%. And these are all estimations, right? Because if I were to do 102 and 108, it would be 108 minus 102 divided by my original value, 102, and that turns into 6 over 102, which is really something like 5.9%. So these are all estimations that we're doing over here. But we get all of these returns, and we can graph them on a histogram of sorts. And my histogram, if I were at 0 and then I have 1, then I can put these into bins. So I have all these 1% and this big 6 and whatever, and I put them into bins. So I got a bunch of 1%, and they go in here. And I have a bunch of -1, -1, -2, -3, 1, 2, 3, and then I've got 1 out here for 6. I'm going to have, if I do this 100 times, I'm going to have a bunch of returns that look something like this. And more, and just a few on the outside, -3, 6. Okay, just a few, very, very few on the outside, and a couple here. And if I make an estimation, then I know that this is going to, if I curve out the top, this looks an awful lot like a normal curve or a bell curve, where the mean is somewhere here in the 0.5. So like 0.5 is going to be my mean. I denote mean with the Greek letter mu, right? Mu is also known as x bar. This is my mean. It is my average value. It is also known as my expected return. And so what happens here? What happens here is I go over and I look at all the historical stock prices. I look at all of these guys. That's terrible. Let me erase that. Control-Z. So I look at all of my stock values up here. I look at all of these stock values, and I take the returns from them, and then I look at what my returns look like over time. Notice that I'm slightly shifted inside of 0, right? It's slightly positive. So over time, if I were to invest in this particular stock, I would expect that my expected return is 0.5%. That means if I invest in this stock per month, I should have 0.5%. So what's my expected return? If this was monthly, I can multiply this by 12 months, and my expected return would be 6% per year. All right, so this is not surprising. This is just, this is just the mean of the historical averages. And we've talked about mu or x bar, and we've talked about what the difference is between why this isn't the actual return, or the difference between expected return and actual return. And so let's take a second and go back to the graph we've discussed in the past, which looks something like this, with risk on the bottom and return at the top. And we know we're going to be looking at expected return, so I'm going to put expected return over here, expected return. And this is going to be in terms of some percentage. And risk is going to be in terms of sigma, or the risk, also known as my standard deviation, which is the square root of variance. And some of this will come back from statistics, and other parts of this we've either done in class or you'll see from previous work. So we have our risk-free rate of return, my risk-free rate here, and again, a lot of this should be from memory. And let me go ahead and just change colors here so we're all in the same place. And over here somewhere, I have some stock that gives me, in this case, a 6% return, which is my expected return. And if I come down over here, I'm going to have sigma sub x. This is expected return sub x. And now I've got a pretty little graph, which tells me how much more return, let's say this is 1%. How much more return over my risk-free rate I am willing, or I need to get, if I am willing to take on this level of sigma. Okay, and that's a pretty important. That's a pretty important definition, because it's going to carry us right into the capital asset pricing model. The capital asset pricing model, and I'm just going to describe it here. We'll do a completely other video. The capital asset pricing model is a relationship that is going to give us a way to value stocks. It is a way to measure expected return. I'll just go ahead and write it out now. It's the risk-free rate plus beta, some coefficient beta, all of this times the expected return of the market minus the risk-free rate. Don't worry too much about this right now. We'll get into it in greater detail here in a second. What is important here is that we talk about where some of this stuff comes from. And so you've got a couple of things that look very familiar here. Okay, so I have my risk-free rate, which we've discussed in detail, and this guy goes here on my equation, and it also goes over here on my equation, right? We all see that. Let me just back it up. And then I have my expected return. In this case, I'm looking at 6% of my stock, and this is going to roughly go in here. I'm sorry. No, it doesn't. Of course not. My expected return is over here, my expected return of the stock. So what I'm going to end up doing is kind of calculate what this expected return of the stock is going to be by using some of this other stuff. And so we are halfway through our CAPM equation as we stand right now. The only thing missing here is my expected rate of return for the entire market. And we'll get to that in a great detail. What is kind of surprising right now is that we have this guy right here, this beta. And beta is going to be our measurement of risk. More of that in a second. Measurement of risk. More on that in a second. But before we keep going, I want to take a look at this. Let's you and me take a look at this. This looks like an awful lot like my risk premium. You guys remember the risk premium? The risk premium is equal to the expected return minus the risk-free rate. The only difference here is that this is going to be the expected return of the entire market, and this is the expected return of the stock. So let's keep that in mind as we move forward into the CAPM, all right? Good luck.